The last part I want to go through with contact is how we deal with shells in Genesis. Shells present just a little bit of a different case because they've got two sides for a start, and they've also got thickness. So how do we deal with that? Okay, and the key thing here is I'm going to take this example, apply a load to the rigid body element where my mouse is highlighting now, and I want to manage the contact between this cross member and the floor, and additionally some contact underneath. So we'll go through the consideration of shell thickness and look at how we manage the contact directions and shell normals with the example. Now, once I'm on here, I just want to show you another function, which is one of our post-processing results envelopes, and I'll do that now. Let's go and find this example. There it is. So here's our model. So first of all, we've got the results with no contact. So we've got two load cases here. So we've got a force on the beam here, and then we have a pressure on the front wall. As you can see, this is a very cut piece of a vehicle body, but allows us to demonstrate the case quite nicely. And what we're going to do is, when we've got something like this, and very often if I have 7, 8 or 9 or well into double figures of load cases, it's very difficult to report and zone on where the issues are. So one of the tips for analysis in Genesis is in the plugins there that we provide as part of our toolkit. You can use this create enveloped result. So what you do, in this case, I've got the two stress results I want to pick. That can be multiple cases, and it can be multiple displacement results types, displacement stresses, composite failure indices, and so on. So we do that. What we're able to do is then look at our combined plot. So this is where all the different parts of the structure are working across all the load cases, so we can understand, report, and then choose to delve into a bit more detail on any areas that are high for further reporting. Another quick tip that's one of those little surprise nuggets of information inside post-processing of Design Studio is if I go to the options menu down at the contour options here, I can choose to have a fixed value. So I may choose to do 70 megapascals as my peak, for example. And I've got that. Now if I want to reset that back to an automatic level, I return here, and the natural method would be to just simply click on automatic, and the scale would return back to auto. But you'll notice that by default it then places a scale factor on the upper level such that it matches my 70. So the trick here is very simply just to double click the word automatic, and you'll see it sets back to a scale factor of 1, which is my true maximum range. A little bit of a secret one there inside Design Studio. Okay, so what I'd like to do now is define some contact between the bar, this cross member, and the floor. And what's important to understand with shells is by default, contact is going to consider the shell thickness. So in this particular case, you can see we've got quite thin parts, so it's less of a significant factor, but still important to remember, particularly if you want to consider gaps and distances in detail and the effect of those gaps. Okay, so you can see here these parts are actually in general not passing through, but we do have some penetration. So what we will do in this example is take advantage of the ignore contact type. Okay, so first of all I will define a new contact set. That's going to be my top member master, and for that I'm going to choose these, and then my top member slave. And what I'm going to do here is choose by feature angle these flanges. I can define that contact, top member. And then I choose to ignore any gap. That solves any penetration issues for this mesh. So as you can see, it's not exactly the most refined mesh example that we're ever going to see. The next contact I want to do is one on this undersurface. Now, this is where we need to just pause for a little moment and think about what we're trying to do with the shell contact. Now, the way contact works with shells is it always searches in the direction of the positive normal, so these surface-to-surface contact definitions. So we need to understand in which direction our normals are going. So on the Elements tab in Analysis, we can pick all the elements in a group, and we can choose to generate the orientation vectors, which are our normals. And you can see here that actually these are pointing upwards. So I raced away in the first contact because they're pointing upwards. And if I also then do a similar thing for the top, these flange directions are pointing down. So that contact was working well. But I've got a slight challenge now because the surfaces on the bottom are going the wrong way. I want to be searching downwards from the floor onto this floor runner. I just check what these ones are doing. We see that these are actually pointing up. So these are absolutely no problem, but these are pointing the wrong way. So there's actually a way to manage that inside Genesis Contact. And so what we need to do is we need to utilize the bsurf-e, which is the element-based contact. So we'll do floor, under. And what we have is this option here to flip the element faces. So if I do that now and then pick the elements on the floor, then it's going to be searching on the underneath direction. That should just remind me I made a little bit of a mistake on this one because this one doesn't want that checked. Okay, so I've done that, and then to complete the contact setup, I can do Underfloor Parts, and I can pick these like so. Define my contact, Underfloor. So we'll have the slave as being the underfloor members, the master as being the floor. We'll ignore our distance and put friction in. And then we'll put all contacts as our settings. NL Palm. And then we'll add these to our load case. And the way it works in Genesis is you can choose to add contacts for your different load cases without a problem. So here I can choose my all contact iteration. And I'll just look at the contact pressures. They're useful to check where contact is happening. And I'll leave the contact alone for the second load case. So let's see if I've got this one done right. Whilst that's solving for all of you attending, I'm quite conscious the time presses on in this session. We're scheduled for a little over an hour. That's about our slot. I would anticipate we're probably going to be near the 1.5 hours. So if there's problems that people want to duck out after that time, I can make sure the recording's available. But hopefully you can join all the way through as we go. Good. There was a little bit of me worried there I'd got that one wrong, and I may still have done. Let's have a look. So here's our initial load case 3 with no contact. And here's our updated. Great. And so we can see that's actually done as we'd expect. And we can actually study the contact pressure. And you can see as a peak as we start to load around the corner here. Good. Okay, so that's, I think, contact fairly well exhausted as a process. Just to recap on some points regarding shells, direction is important. Please always check it or it will not work. And secondly, if you're doing iterative contacts, which is what we've focused on here, glue contacts are the same setup process, but just simply there's no iteration. Both methods for shells consider shell thickness. If you do wish to consider the contact to be on the actual mesh surface itself, then within Design Studio you can go to the Genesis options menu, choose analysis, other parameters, and you can add in either the BC search or GL search options to 0, which will define them to be on the mesh surface. And that's again quite often a useful method to consider.